forget the textbook definitions that most people, they know OLTP is for transaction while OLAP is for analytics. But here is one question that nobody wants to answer. Why do business need both of these systems? So in the next few minutes, I'm going to build an OLTP data model and an OLAP data model so that you can see how the operational data becomes analytics data. So now let's see the difference between the OLTP system and the OLAP system. But before we explore the difference between these systems, first of all, we need to understand the entire end-to-end life cycle of a BI project, BI or data analytics project. So this is the rough, let's say, skeleton of a BI life cycle of a BI stroke data analytics project. So here we have the users. So the users here, you can see they interact with the application, and then the data is stored into these systems, and then the data is pulled into this system, and then here is the we do the transformation, and then is the data is stored into this another system, and then we do reporting, and then we finally use our data for the decision. So let's start from here. So these users can be me and you. So when, for example, you do a transaction in Amazon, when you buy something, when, for example, you send money to your relatives, when, for example, you're interacting with tools or applications such as LinkedIn, maybe you're creating posts, maybe you are commenting on Instagram, Facebook, TikTok, and so on. So once you interact with this application, you normally generate data. So this data is normally stored into a system or a storage system. So this storage system is what we call OLTP system. So you interact with the application, example, LinkedIn, Facebook, maybe Amazon websites, and so on. So once you interact with this application, you generate data, and this data is stored into the OLTP system. So example of this OLTP system can be relational database such as PostgreSQL, MySQL Server, SQL Server, MySQL, and so on. So this OLTP system, they are designed in a way that it allows fast transactions. This system, they are designed in a way that it allows fast transactions. So once this data lands into this OLTP system, we cannot directly pull this data from this OLTP system into let's say, for example, if you want to analyze the data, maybe you want to see the total revenue. For example, if you are in a business, you want to see the total revenue that your business generated in the last, let's say, 1 month. So in that connection, you cannot pull the data from, like, you cannot pull the data. It's not recommended for you to pull the data from OLTP system into the, let's say, Power BI for you to create that visualization. So in that connection, we normally create another system. So this system, we normally create this system, and this system is what we call OLAP. So we're going to pull this data into the OLTP system, and then we store them into the OLAP data OLAP system. So example of the OLAP system, they include Snowflake, BigQuery, Databricks, Redshift, and so on. So these kind of systems, they are majorly for analytics and reporting or side of the business. So in case we need to do the, let's say we want to use the data for our maybe Power BI reporting. We will going to pull the data from this system into our Power BI, and we build the visual, which will later on, out of those visual, the insights and the dashboard, we can then generate insights from those dashboard, and finally we can make decision out of our data. So there's a difference between this OLTP system and OLAP system. So let me share you the two difference between these two systems. So let's start. So let's start with the two difference. So difference. So the two difference, let's just say difference. So one of the difference is, number one, the tools. Let's stop technology. The tools used to make these OLTP system are different from the technology used to make this system. So for example of the tools used in OLTP system are PostgreSQL, MySQL, SQL Server, and maybe Oracle. And then the tools used in OLAP system include Snowflake, BigQuery, and maybe Redshift. So these tools, for example, the tools used to design the OLTP system, they are designed in a way that it supports the transaction, or it allows the transaction of, it allows faster transaction, because remember these system, they store the transactional data or operational data. So that means this system should be designed in a way that it supports the transactional data, so that we allow this user to interact with this tool, with this application, without any, let's say, any delay, or without any with faster in terms of performance. So these tools, they are optimized in a way that they allow fast transaction or operational. And then these tools that are used to design this OLAP, the tools such as Snowflake, BigQuery, and Databricks, they are designed in a way that they allow faster analytics, data analysis, and reporting. They allow in a way that if you want to pull the data from these tools to Power BI, it's become faster. The query of pulling the data from this data warehouse to Power BI is normally faster compared to this. So this one, the tools are designed in a way that there's faster data analytics and reporting, while this one, the tools are designed in a way that there's faster transactions. And then the second difference is the way the data is stored, the way data is stored. So the way data is stored in this system, OLTP system, is not the same whereas the data stored into OLAP system. So for example, in this OLTP system, the data is stored in a way that it will allow fast transaction or operations. While in OLAP, the data is stored in a way that it allows fast data analysis and reporting. So those are two differences between these two systems. And then we a lot of beginners, they've been asking me, why should we create OLAP, yet we can simply pull the data from the OLTP system into reporting tools. Why create OLAP? So the question is, why create OLAP and not maybe why create OLAP if the data is already stored in OLTP. Yeah, so this is the question I normally, a lot of people, they ask me, why should we create this OLAP? Why should we create this OLAP instead of just pulling the data from the OLTP system into the Power BI or Tableau or Excel to do our reporting? Why should we create this? So here is a good example. So let's assume here you have the OLAP. Here you have the So let's assume here you have the OLAP. So let's call this OLAP, OLTP. OLTP. So this is our OLTP. And so in this OLTP, as we've discussed, is normally for transaction. So let's say this is transaction. And then here, let's say for example now, manager want to get report for, let's say, last month revenue. So here we have manager asking manager report. And then here we maybe finance team also, they are calculating. They are using this they're pulling data from this database. So finance also, they use this, let's say finance use. And then here we have also, since we've connected this database directly into our BI tools, so that means that means the BI, for example, if it's Power BI, that means the Power BI is pulling and refreshing data from this. So let's say here you have Power BI also. Yeah, so you see all these activities, they are operating in this same database. So what will happen is that So what will happen? The problems that will occur, problems that might occur. So one of the problem will be something like this database will slow down. The database slows down. Number two, also the reports from this Power BI, the reports will take long to load. So let's call it two slow reports. Number three, also the transaction that are done by this customer. The transaction will also take long to load into this database. So let's say slow transaction. Slow transactions. Also, since the transaction they take so long to load into this, that means there will be poor user experience, like this customer who are interacting with the application, as we've seen here. Customer interacting with the application or doing that application, but in this system it's loading, or it's if the system is slow, that means this customer, there will be poor customer experience. So 4 can be poor customer experience. Poor customer experience. Also, since all these activity they are happening in the same database, that means the higher server cost increases. There will be higher server cost, because all these activities, they normally consume what we call compute power. So the more the activity they are happening in the same database, the higher the computing power they consume. Hence, server cost become also higher. So 5. So here can be higher server cost. So here you have higher server cost. So instead of you pulling the data direct from OLTP system, you need to create another data warehouse to reduce the burden of this OLTP. So in that connection, so we have to create another warehouse. So this another warehouse now is what we call OLAP. So we will going to create another environment for analytics. So instead of you burdening this OLTP system, we create another OLAP. So this OLTP system, we can only leave this OLTP system for the transactions alone, and these other activities we can take them to the OLAP system. So these activities like the one for manager, the MR, the manager needing a report, another activity like this one, the finance using the data, the few, and then the activity like the Power BI refresh, Power BI, and then we leave this system with only so we leave this system with only the OLTP. So we only leave this system specifically for transactions. We only leave this system only for transactions, and all the analytical related will be done in OLAP. So I hope you've clearly understood the difference between these two, where this one is for transaction while this one is for analytics. So the tools designed for this system, we've seen they're optimized for transactional stroke operations, while the tools designed for this system, they are majorly designed in a way that they are designed for analytics and faster analytics and reporting. So I think that one is very clear. So here the just a general difference between the OLTP system and the OLAP. So we have the OLTP system. This one is for running the business as the customer makes the transaction. As the customer makes the transaction, this transactional data is stored into the OLTP system. And then when manager wants, for example, analyze the data, or want to also maybe, for example, finance, or just any other person who want to use this data, they normally access this data from the OLTP system and do the analysis. So OLAP is for analyzing the business, while the OLTP is for running the business. So those are just some few example of, the difference of OLTP and OLAP. So this is some good definition of OLTP. So OLTP system, so these are your application database. Yeah, so here you have the application, and this application, they contain the database storing the data that will come from this application. So these are your application database that powers your website, mobile apps, and API. They handle individual transaction of the business. Example of the transaction can be customer places an order, payment is made, product stock is updated, new customer registers, and all this, the data that are coming from this transaction, they normally stored into the OLTP system. So this OLTP system, as we've learned, they are good for inserting and updating the individual records. Data integrity, there's no duplicates, then there's no consistency, there's no orphaned records, and then we have normalization. So in this in this system, we normally do what we call normalization, where we split the data into many tables so that we can reduce the redundancy. So in normalization, we shall going to see more about the normalization in the next session as we build this OLTP system from from scratch. And then we have OLAP, online analytical processing system. So these are your data warehouse. Example include Redshift, Snowflake, BigQuery, and so on. So they handle analytical queries. So the data from OLTP system is moved into the warehouse, data warehouse. So the data from OLTP system is moved into the warehouse. And this process of moving this data from the OLTP system to the warehouse, we normally extract the data, we transform this data, and then we load the data into the warehouse. So this entire process is what we call ETL, the extract, transform, and load. Extract the data from the OLTP system, use transformation tools such as dbt, Python, and then we load it to the data warehouse. And then from this end now, we can use this data and pull it to Power BI and do the data visualization. And then from the data visualization, we can be able to make decision out of the insights that will come from our dashboard. So I think that one is very clear. Yeah, so the data is moved from OLTP system into the data warehouse for reporting and analytics. So the business user asks questions like, which product sells most, which region generate highest revenue, monthly sales trends, the customer retention. So all these we're going to analyze. So going to use the data originated from the OLAP, and then we use the BI tools like Tableau, Power BI, Looker, or maybe Excel, and then we can answer all these business users question. The OLAP system are optimized for fast read, query simplicity, denormalization, and so on. So I think this one is very clear. So we've seen the difference between the OLTP system and the OLAP systems. Now let's start building a data model for the OLTP system. So let's assume you're a user of Jumia or maybe Amazon, and you go to their website or maybe use application, do place an order, and then so this data it will be stored into the Amazon's storage system or the Jumia storage system. So these storage systems is what we call the OLTP system. Now we are building the data model for that kind of data. So let's assume that data is stored in this format. Where we have the order ID, we have the order date, we have the customer name, the gender, and then here we have the product information, cost price, and then we have the sales. So if you look at this data, you'll find like there's some problem that we need to sort it out. So for example, when for example a customer makes an order, we need to enter the details, the full details of that customer, from the order ID, the column date, customer name, gender, age, product, cost, category, sales, and so forth. So that means the inserting of data, the process of inserting of data will be slow. So that means there'll be poor performance in terms of performance, because remember a company like Amazon, it deals with millions of data. Now each and every let's say transaction will have to enter this kind of details, full details of the transaction, from the order ID, order date, customer ID. So it's a bit slowing the data insertion. So one of the problem of this data So let's write here the problems. So one of the problem, sorry, let's write here. So one of the problem is poor performance. Poor performance due to, let's say, many columns. I.e., say data insertion, inserting of data is slow. Yeah, so this is one of the problem here. Another problem in this data is that there'll be, for example, this customer 001, that is Brian Otieno. He made an order in this date, and also he made an order in this date. So you can see once the customer makes an order, we'll have to write the full details of that particular customer. So let's assume this Brian Otieno made, let's say, 20 orders. So therefore, that means we will have to keep on repeating the same details of Brian Otieno up to 20 times. So that means there'll be more of like a repetition of the information. So in that way, it will lead to what we call data redundancy, where we are repeating the same information instead of just maybe just write maybe customer ID, and we fix that problem. So the second problem is what we call data redundancy. The second problem is called data redundancy. Data redundancy, where we can see a lot of information. Same information, they're being repeated each and every orders. Same to products also. So you can see like this flour of maize, several let's say customer here can make orders of the same products. So that means we'll have to keep on repeating let's say the details of this, let's say, product. So that's also part of the data redundancy. And also another problem is that let's say, for example, this product here. So this product currently it's 55. The cost price is 55. Now let's say these products here, the unit price changes from maybe 55 to, let's say, 50. Maybe it changes to 50. So you'll find here there'll be no data inconsistency. There'll be data inconsistency because you'll see like some rows will be having 50 as the cost price of Brookside milk, while some row will have 55 as the cost price of Brookside milk 1 liter. So that means there'll be data inconsistency. So the third problem will be data inconsistency. Data inconsistency. So these are the major problems that our data is currently, our data stored in the OLTP system is currently facing. So we need to provide a solution for this problem. So we'll have to provide a solution to this problem. So the solution of this problem is what we call data modeling. So the solution here is data modeling. So data modeling basically is how we design our data, is how we is the, let's say, the process of designing our data in a way that we solve these three problems, in a way that we don't have data redundancy, we don't have data inconsistency. Also, the inserting and updating of data is much faster, and so forth. So let's start building the data model of our data. So here, so this is the main table, and if you look at this main table, it contains three entities. It contains the orders details. It also contains, orders. So let's just write here. So currently our table, it contains three entities. It has orders plus customers information plus products information, products informations. So we will going to first of all extract. We shall going to build tables of these three entities, where we shall going to have the customer information in its own table, and then the orders information in its own table, and then the product information in its own table. So this process of breaking down this larger table into smaller tables so that to reduce redundancy is what we call normalization. So we are just breaking down this larger table. So here we have let's put this way. So we are breaking this larger table. We are breaking down these larger tables into smaller table. And then yes, so for this one, maybe this one will be orders table, orders, and then this one may be the customers table, customers, and then this one will contain the products. So we are breaking down this large table here, this large table into smaller table. So one of the smaller table will be orders customers, and products. So we're breaking down to make sure that there's no data redundancy. So that means even this smaller table also, if there's data redundancy, we're also going to break them into smaller table. So for example, this one, customer, we can also break it into smaller table. Maybe, let's say we want to extract the table for, let's say we want just to have a table for gender, where we have a table specifically for gender, because we don't want to have data redundancy in terms of the gender. Also here we can also break this products table if there's data redundancy. Maybe there's repetition of the products category, we can decide to put another table for specifically for that products categories. Yeah, so let's say this is a gender table, and let's say this is a let's say product category. Product category. So this process of breaking down the tables to smaller table, so that we can reduce the data redundancy, is what we call data normalization. Data normalization. So let's just write here. This is what we call normalization. Normalization. This process of breaking down these larger table. So the first table contain this. So let's copy this one here. So the first table, this one, it contains these details of orders, details of customer, and details of product in the same table. So for us to reduce the data redundancy, we'll have to break this large table into orders, customers, and products. And then if we see the data redundancy from these, let's say these smaller customers, these smaller tables like the customer and products, we can further break them into another smaller tables. Let's say, for example, for customer, we can further divide this into, let's say, table gender. And here also same to products, we can decide to divide it into also product category. So this process of breaking down the larger table into smaller tables so that we can reduce redundancy is what we call normalization. Normalization. Okay, let's just leave that way. Yeah, so now let's start breaking this table into the smaller tables. So let's start with the customer. So customer here, So let's extract the customer details here. So copy this and then you bring it here. Customers. So in this customers table, so let's just call it customer. Customers here. So in this customers table, we will only bring the we only want the distinct customer details here. So that means we'll have to remove all the duplicated customers. So for example, this one we have, so this one we'll have to delete it. Let's say clear content. Let's just remove it. Yeah, and then also 3 here. This one also will have to remove it. And then is there any repetition? Yeah, 4 here. Also 4 will have to remove it. And then 2 and 5 here. Delete 5 also, we delete. So now we have distinct customer. We have customer 1 up to customer 10. So here we will create a unique identifier. We'll create a what we call primary key. So we're going to create a new column here and we call it customer key. So call it customer. Let's call it customer key. Customer key. So this customer key will be our primary key. So so this customer key will be our primary key. So primary key is basically a unique identifier of, for example, of these customers. So that means each customer will be represented by a unique customer key. So let's say customer 1 will be represented by unique customer 1, here maybe 2, here 3, 4, no 4, then you have 5, then you have 6, and then you have 7, and then you have 8, and then you have 9, and then we have 10. 10. So you can see each customer is represented by a unique customer key. So now we will have to go to this table to replace this customer ID with this customer key. So let's call this one. So let's just call this one customer key. Customer key. Customer key. So now, for example, customer 1, this one will be customer key 1, this one will be 2, this one is customer 3, customer 001, this is customer 1, customer 004, this is 4, 5, this is 5, this is 6, this is 7, this is 8, sorry, no, this is 3, this is 8, this is 4, this is 9, this is 9, and here this is 10, this is 2, and then this is 5. Yeah, so we have our customer key populated into these orders, or we've replaced the customer ID with their respective customer key. So now we can now remove these other details like this one. So we don't need these here, so we can simply clear the, let's say, clear the content. So now we have so let's bring this one here, copy, and yes, so let's remove this. Yeah. So now we have successfully removed the customer details from this orders table. So now also get rid of this product ID. We also need to create a product, we also need to create a product table. So let's write products here. So products, so let's bring the products details. So these are the products details, and then we copy it here. So here also we need only, so in these products details we only need the unique products. So the unique products, so 1, 2, 3, 4, so 2 is not required to be here, so that means we'll have to delete. And then 5, 6, 1 is not supposed to be here because we only want the unique. And then here we have 4, delete, delete. So we have the unique also product here, where we have product PO1 up to product 001 up to product 010. So we're also going to create a primary key for this, so that each and every product can be represented by a primary key. So let's going to call this one as just product. Let's call it product key. So this one is primary key. our primary key, so it will represent each and every product. So for product P001, we can make it represented by 1, 2 for PO2, P002. Here we can make it 3, here 4, here 5, here 6, here 7, 8, here 9, here 10. So we have our products table here. So we're going to replace it with so now this one, let's change this one to be our product key. So now 1, we're going to replace it with 1 P002. This is 2, this is 3, this is 4, this is 2, this is 5, this is 6, this is 7, okay, this is 8, this was 7, and then this is 8, this is 9, this is 10, this is 4, this is 6, and this one is 3. So now we have the product key. So each of these product detail is represented by a product key. So therefore we don't need all these other columns, so we can remove these. So let's just clear content, and then we take this one here, copy, here. So let's remove this. Yeah, so now we have our orders table here, as you can see. So now we have our very cute orders table, and we have our customers table, and then we have our products table. So if, for example, a customer wants to buy, makes an order, you can simply, we will only going to, you can see the columns. You can see we only enters these very few columns where we order ID, order date, customer key, product key, and the customer's sales. So the previous one was container. The order ID, order date, customer ID. You know, the previous one was very, very long. So that means the inserting of data was taking too long. Maybe the performance was very slow. But this one, we can insert our data much faster compared to the previous one. And if, for example, a new customers buys new item, that means first of all the new customer will have to register. So if it's new, so then therefore we'll have to register, so it will be maybe 11 and then the customer ID and the customer name, the gender, or the age. So he'll have to register, so that means when he do the registration, his detail will be populated on the customer. That's why in Jumia or in Amazon, you'll be required to register with the Jumia or Amazon before you start doing the transaction. So once they register, their name you simply their name simply inserted into the customer's table. So once they do once they start ordering item, so their name will be, their details will be order ID, order date, and here the customer key will only going to enter the customer key here, and the products they've ordered, product they've ordered, and the product they've ordered, we will also going to write it here. We'll simply going to write the product key of the products they've ordered. So you see, like, it's become much easier in case you want to change the cost price of, let's say, the cost price of Brookside, for example. If it changes, you can simply come here and change it to maybe the 50. So now you see it's now become faster, easier, and the performance is very good. But here there's still a problem that we also need to break these here, like there's still a problem. Like, for example, here the gender, you can see there's a redundancy in gender. So that means we can further break this customers table into another smaller table. So here you can see, as we've said, this process of breaking down the larger table into smaller tables to reduce the redundancy. But here in customers table, we also have some redundancy in gender, this gender. So therefore we can create a new smaller table. So let's call this new smaller table as gender, and then this gender, so gender is male and female. So let's first of all highlight this one to, so let's have the gender here, and here we're also going to have for this one will be gender key, gender key, gender key. Gender key. So for the gender key, so the gender here, the value of gender is male, and female. So the male can have can have gender key 1, and for the female can have gender key 2. So here we'll come and replace with the gender key. So like you can see, instead of us writing the whole entire name, we will only going to write the gender key. So that one will reduce the space, like male and female. This one takes more space than just if you write 1 and 2. So let's write this one as gender key, and then we replace the male. And so for male, this one is represented by 1. For female, this is 2. For male again, this is 1. For female, this is 2. For male, 1. For female, 2. For male, 1. For female, 2. For male, 1. For female, 2. So this one will help us to reduce the spaces. So this also will help us, eventually will going to help us improve the performance of our, let's say, system. So that means we don't have any data redundancy currently. And so let's move to this other one. This other one also, you can see there's data redundancy here. Food is repeated, also repeated, dairy. So there's kind of the duplication of data in this. So that means we also need to create a table specifically for this category. So let's say category here. Category. So category, so this one will have, let's put the category column here. So we have how many categories? We have food, and then we have dairy, and then we have grocery, and then we have bakery, and then we have beverages, and then we have household. So let's put this into, yeah, and then here also we're going to call this one as category key. Category key here. So less food represented by 1, dairy represented by 2, grocery represented by 3, bakery represented by 4, beverage 5, and household also 6. Now we'll have to replace this category with the category key. So let's call this one key, category key. So here food is represented by 1. Here we have dairy represented by 2. Food again, this is 1. Grocery, this is 3. Bakery, yeah, bakery, this is 4. Beverage, this is 5. Dairy, this is 2. food, this is 1. Beverage, this is 5. Household, this is 6. Yeah. So now we don't have any redundancy in this table, and you can see all our table, they are very, very cute. Yeah, so this process of now, the process now where we have broken down this the larger table into smaller related table is what we call data normalization. So I hope you've clearly understand this whole process. Let's now design the OLAP model. Since we are done designing the OLTP system model, now let's focus on designing the OLAP data model. So in OLAP, we normally build the data model by doing what we call dimensional modeling. Here we use dimensional modeling to come up with the OLAP model. And in this model, we use the concept of facts and dimensions. Facts and dimension, where we will going to build facts table and dimensional tables. So first of all, we need to understand what is this facts table and what is this dimensional table. So facts table, generally they contain the transaction of the business, while dimensional table here, they provide description, they provide context. So for example, in our table here, you can see this table contain order details, customer details, and product details. So our table contain order details, orders, plus customers plus products details. So that means we're going to come up with 3 tables using these 3 items here. So these tables that will come from this combination, some of them will be facts table and some of them will be dimensional table. And we've said facts table, this one, they contain the transaction of table. So that means order table will contain the orders, and orders are the transaction of the table. So that means facts table here will be fact table. Sorry, here will be orders table. Let's call it this one, orders table. And the dimensional tables here, dimensional table here. So dimensional table, as I've told you, they provide more context. So for example here, customer, this table will contain the details of the customer. So this table will contain the descriptions or the context of the customer. So that means customer is a dimensional table. So let's have, so the dimension table here will be customer, and also products also, because products, it provide more, it provide description about the products of the, let's say, of the company, yeah. So let's copy and say, yeah, so we have facts table, orders table, and then we have products table, and customer table being dimensional table. So here we shall going to have the orders table being the facts table here, and then we shall going to have these two dimensional, yeah. So here is the orders, let's call it now facts orders, and here we have let's say time products, and here we have, let's say, time customers. So these are facts table are the table that contains the transaction, while this one are the table that provide more description about the entity. So for example, here time customer, this is a dimensional table because it provides more context about the customer. And this facts table, it contains what we call foreign key. So while this dimensional table, they contain primary key. So now we shall going to, so since facts table contain the foreign key and dimensional table contains the primary key, therefore there will be a relationship among these facts table and the dimensional table. So this will have relationship will have a relationship. So this kind of data model is what we call star schema. This is what we call star schema. So now let's practically do it using our table here. So let's first of all build the dimensional customer. So we shall going to build the dimensional customer by extracting the all information about this customer. So it starts from here. So copy, and let's just put it here. let's just put it here. So we only want the distinct customer here. So let's call it this one as dime customers. So let's highlight this. Yeah. So this table will only contain the unique customer. So that means we'll have to remove some of the duplicated customer here. So so like this one, this is a duplicated customer. So we'll have to simply remove it. Another one, 3 here. So let's remove it. And then we have 4 here. Also, it's a duplicate. So we only want the unique customer here, and then we have this one also 2. 2. Then also 5. So we remain with only the unique customers here. So in that, here we shall going to come up with another column where we shall going to assign each customer with a unique, let's say with a unique ID. So that means, so let's call this column as customer key. Customer key. So each customer will be represented by a unique customer key. So let's start. So for example, C001, we can represent it by letter 1, here 2, here 3, here 4, 5, 6, 7, 8, 9, and 10. So this is our dime customer. So now we shall going to replace this customer ID with the customer key. So let's remove. So now let's replace. So for example, 001 is represented by customer key 1. So 001, here we have C002, here we have C003, here we have C001, here we have C004, 5, this is 6, this is 7, this is 3, this is 8, this is 4, this is 5, this is 10, this is 2, and this is 5. So we have each customer is represented by a customer key here. So now this, let's call this one as customer key. So now that we have our customer key here, so this customer key in our dimensional customer will be our primary key. So let's highlight this. So this customer key in our dimensional customer will be the primary key. So let's label it as primary key. So this one will be our primary key, while the customer key in this facts in this facts table. This one will be our foreign key. So after that, now we're going to remove all these details of customer, since we've created a dimensional customer table here. So let's remove this. Yeah, so we can remove by now let's just clear content. So now we have this product and the sales. So let's just put this, let's bring this product, this other close to this, so we can remove this. Yeah, so we have our customer dimensional table here, and here we also need to build a product dimensional table. So that means we're also going to fetch or extract all the data related to products. Copy and then bring it here, and we call it. So this one also going to remove all the duplicated products. So let's start with this one. Remove it, and then also one here, we remove it. So any other duplicated, yeah, we have 4 here, we remove it, and then we have also 6 here, we remove it, and then we have so we also have 10 products. So this is our dimensional products table. So let's call it dime products. Yeah. Yes, so let's highlight it. Yeah, so this one will also come up with a unique identifier. So we'll come up with a product key, a column for product key. So this product key will represent each product with a unique value. So PO1, this one we can present it by 1, this one 2, 3, 4, we have 5, we have 6, we have 7, we have 8, we have 9, and then we have 10. And also this product key will be our primary key. Yeah, so now let's go to this our transactional table, our facts table here, and replace this product ID with the product key. So let's call this one product key. So product key here in facts table, this one will be our foreign keys. So here PO1, this is 1, PO2, this is 2, this is 3, this is 4, this is 2, this is 5, this is 6, this is 1, this is 7, 8, 9, 10, 4, 6, 3. So we have replaced this the product ID with the product key. And then after this, we will going to remove all the other column for products. So we can just remove. Let's clear content. And then you can take this one here to here. And then this one we can clear. So we have our dimensional products, we have our dimensional customers, and here we have our facts orders. Facts orders. So as you can see, we have splitted the original table with into facts table and dimensional table. So we can build the relationship among the facts table and dimensional table. So for example, we can connect this facts table with customer table using customer key, because it has customer key as the foreign key. This facts table has customer key as the foreign key, while this dime customer table has customer key as the primary key. And then here dime products table, it has a product key as a primary key, and facts orders table, it has product key as a foreign key. So that means we can join the foreign key with the primary key. So as you have seen here, where we have gotten our facts orders and our dime customer and our dime products. So let's see the summary. So this is the summary. This is the structure of our data model in OLAP system, where we have the facts and it's connected directly with this dimensional table. So this kind of data model is what we call star schema. You can see facts is at the center and it's directly connected with all the relevant dimensional table. So let's have a summary here. So facts table, this one contain matrix and foreign key, and dimensional table, this one they provide context. So for example, date is a table specific for dates, so it gives more information about the dates, that months, day name, quarter, all those kind of data related to dates. And then here we have also, for example, table products. So these are tables that contain the description about the products in terms of product ID, product name, category of the product, the unit price of the product, and so forth. And then here we have also customer, generally gives more information about the customers, and same to store. And here we have foreign key. So we connect facts to dimensional. So we use foreign key to connect fact to dimensions. And then we can see here also denormalized. You can see dimension are not further normalized or are not further split, as you've seen in this. Here you can see this dimensional, even though we have redundancy data here, but we cannot split further into smaller tables, as you can see. So for example, here we have a redundancy data of the category, but we cannot further split them into smaller tables. So that means we have denormalized our table. When we split them further to smaller table, now we are doing what we call normalization, where we are splitting the data into smaller tables until so that we can reduce the data redundancy. Yes, I think that one is clear. And then query performance. So we write simple joins and fast aggregation. Yes, so for example, if you want, for example, the total sales of product P1, so that means I'll join these two tables. The table containing the sales information, which is facts order, and the table containing the product P01, P001. So I'm going to join them using the foreign key, product key, and the primary key, product key in the dime products. So it's very simple. You just join the two tables and you get your output as fast as possible. And then here, so this is the summary of the OLTP and OLAP, where we have the features, and here we have OLTP, OLAP. So you can see the purpose of designing OLTP. We normally design this for transaction, for faster transaction. Here is designed for analytics. Data, this one holds current data, while this one holds historical data. And then the queries here fast, small and fast. Here the queries are complex because since we are dealing with the current data, that means we are just dealing with just a small number of data. Well, since we are dealing with historical data, that means the data is from maybe, let's say, from where the organization. So dealing with that kind of data is very complex and heavy. Example, placing an order, revenue trend analysis in OLAP. Normalization, this is highly normalized, is where the table is split into smaller and smaller tables, while this one, the table is just split into the facts table and the dimensional table. And these dimensional tables, they are not further split into smaller tables. They're just split into the dimensional tables alone. They're not further split into smaller table from there. And then, so this one, they store their data in raw form, while this one, they store their data in column form. So I think that this session, you've enjoyed this session. Thank you.